है ना मुझे कि जब मैंने मोल्स कैलकुलेट किए ना, तो उसके जाहिर सी बात है उसको या फ्रैक्शन में एक्सप्रेस कर सकते हो मोल्स को, 1/342 आंसर आ रहा था, या उसको तुम डेसिमल फॉर्म में लिख दो। तो जब मैंने उसको डेसिमल फॉर्म में उसको डिवाइड किया ना उसको एनर्जी को, तो मेरा आंसर जो था थोड़ा सा स्लाइटली डिफरेंट आ रहा था, और जब मैंने फ्रैक्शन फॉर्म वाले से डिवाइड किया तो आंसर थोड़ा सा डिफरेंट आ रहा था। लेकिन मार्किंग स्कीम में जब उसने लिखा कि 3 सिग्निफिकेंट फिगर्स तक इसको राउंड अप करो, तो फिर इन दोनों इसमें फिर बहुत बड़ा फर्क आ रहा था सर आंसर में, इन दोनों इस छोटी सी स्लाइड चेंज से। तो मैंने कहा सर पेपर में ऐसा ना हो जाए, फिर इसका क्या करना चाहिए?
नहीं, मुझे नहीं समझ आया कि एक सेकंड फिर से बताओ कि जो मोल था।
यस सर।
जस्ट वन सेकेंड। अच्छा, मोल जो था वो तुमने क्या किया कि क्वेश्चन में कि फ्रैक्शन फॉर्म में था, और
लेकिन सर उसका था, हाँ लेकिन उसने बोला था 1 ग्राम ऑफ सुक्रोज। सही है।
अच्छा, 1 ग्राम सुक्रोज, ठीक है।
1 ग्राम
क्वेश्चन बता दो,
सुक्रोज हो
सॉल्व
गया।
कर लेते हैं। क्वेश्चन पता है कोई?
अच्छा
कौन सा? वो किधर
हाँ
सॉल्व
सर
कर
मुझे
लेते हैं।
पता है सर,
हाँ,
ये जो है ना, मैं दिखाता हूँ एक मिनट।
कौन से पेपर का?
ये
9701?
नहीं सर, ये मैं टॉपिकल करा था थोड़ा सा रिफ्रेश करने के लिए।
ठीक है, तो एमसीक्यू था या क्या था?
कुछ ये इतनी थ्योरी है, ये मई जून 2022, सॉरी मई जून 2020, सॉरी।
अच्छा, समर
वेरिएंट
20 और
22,
क्वेश्चन पेपर
वेरिएंट
22।
22।
ठीक है, जस्ट वन सेकेंड।
क्वेश्चन नंबर 3।
अच्छा, क्वेश्चन नंबर 3, जस्ट वन सेकेंड। अच्छा, ये वाला ठीक है।
यस सर,
तो
इसका डी
अच्छा
पार्ट।
इसको, अच्छा तो इसको लेट्स ट्राई एंड सॉल्व दिस। you've got 1 gram of sucrose, ठीक है। तो this is given and you're being given the heat energy produced is used to increase the temperature of 250 grams of water from 25 to so you can use Q is equal to mc delta T, ठीक है। तो that's 250 grams multiplied by the specific heat capacity of water, which is in the data booklet, I think that's 4.18, and delta T is what? क्या आ रहा है? That's 15.7.
यस सर, 15.7 आ रहा है।
अच्छा, तो इसकी क्या वैल्यू आ रही है ऑन योर कैलकुलेटर?
सर इसकी
एक सेकंड, लेट मी। Okay, 250 into 4.18 into 15.7, ठीक है। This comes out to be 16,406.5, लेकिन it's in joules, ठीक है। अच्छा, ये remember this thing कि Q is in joules when you do mc delta T, especially when you use 4.18, ठीक है। Is that clear? So अच्छा, the next part is कि he's asked you to calculate the enthalpy change for the combustion of sucrose. That is for 1 mole, ठीक है। So you have to figure out, you got to use ratios के 1 gram sucrose में how many moles do you have in 1 gram?
1/342 आता है सर इसका।
नहीं, confirm है 12 carbons, that's one
यस
second.
सर, 1/342।
12 into 12 plus 22 hydrogens,
Yeah,
plus
342
16 times 11, 342, ठीक है।
यस सर।
अच्छा, so 1/3 कितना? 1/342, right?
Yeah.
अच्छा, 1/342 moles
Yes sir.
produces this much energy, ठीक है। So basically you just have to figure out कि बस और कुछ भी है। So 1 mole would produce how much? Using ratios it's going to be
सर एक मिनट सर, प्रॉब्लम यहाँ पर आया था मुझे।
हाँ,
देखिए 1/342 का डेसिमल फॉर्म में लिखें जरा।
So 1/342, if I remember 1/342
in decimal form.
हाँ, वो फिर वो रिकरिंग कहाँ आ जाएगा ना, that's 0.0293, वो एक बहुत लंबा चौड़ा नंबर है ना। मैं वो कर लेता हूँ, मैंने कहा था कि मेक श्योर कि डोंट ट्राई टू राउंड ऑफ वैल्यूज बिटवीन द स्टेप्स, ठीक है। कि इफ यू ट्राई टू राइट दिस डाउन इन डेसिमल फॉर्म तो यू वुड हैव टू राउंड इट ऑफ। जब आप बीच में, व्हेन यू राउंड इट ऑफ टू मेनी टाइम्स you'll get a rounding error, ठीक है। when you don't try to round it off then there won't be any errors due to rounding, ठीक है। क्लियर है? तो इसके अंदर if you're getting 1/342, I mean that's not the answer. The answer has to be rounded off up till the appropriate significant figures. तो बीच में ना between the steps don't try to round off values. So this would come out to be what? क्या होगा? It's going to be 16406.5 divided by 1 with 342, right? Which is basically into 342, right?
Yeah.
So क्या बनता है? This would become into 16406.5, 1606.5 and into 342, right? Just 1 second. And the whole thing will be in kilojoules, it would be divided by 1000.
Yeah.
So I'm getting 5610. 5610. So we error is, remember the error is the rounding error. ठीक है? Don't try to round off values between the steps. मतलब even अगर यहाँ पे लिख रहे हैं ना, do one thing. Like if you want to write it in decimals, right? If you do 1 divided by 342, ठीक है? This gives me a big number. I mean, in decimal wise, it's many decimal places, right? So what you can do is, if you're writing it on paper, you can try to round it off till the appropriate significant figures. Make it 0.0029. 292. Okay, this comes out to be 0.00292. But on your calculator, don't use this value. Use the big value, which I'm getting on my calculator. That's 0.00292. And after that, there's 397660,819. Okay, so it's a big, lots of decimals after that. So on your calculator, don't try to round off things. Okay, but अगले step में ना, use the value that you got on your calculator. Is that clear?
Yes, sir. Sir, इस गलती की वजह से मेरा आंसर 5620 आ रहा था.
हाँ, तो उस पे मार्क कटेगा ना पे एक.
हाँ.
ठीक है. So just make sure के don't round off things. I mean, when you're writing things on the paper, you would have to round it off. वो जो rule है ना, appropriate significant figures, that if this is 3 significant figures, your answer cannot have an accuracy greater than 3 significant figures. So you're going to round off things up till 3 significant figures. Lekin, even if you're writing stuff, rounding off things between the steps, make sure don't do it on your calculator. Take the most accurate value forward, and then use that value to get the final answer. Okay, so that's going to be your final answer. Okay. चलिए clear है?
Yes,
अच्छा, so let's try and do this question. कहाँ गया? अच्छा, let's try and do February March 2022. Starting with the first thing. This paper, iodine is found naturally in compounds in many different oxidation states. Iodide react with H2O2 to form iodine and water. The reaction mixture is shaken with cyclohexane to extract the iodine. So what paper is this? This one is this is the latest one. This is paper 4. I need to forget this. That's paper 4. We're supposed to do this one. W2. Yeah. Okay, let's try and do this one.
सर हाँ जी सर, टाइट्रेशन कर्व्स का और जो है वो जो भी लेटेस्ट जो आया उसमें क्या बोलते हैं दूसरा एनालिसिस में जो था
क्या था
वो कर सर कुछ तो एनालिसिस का सर वो क्या होता है सर वो फ्रैगमेंट्स वाला जो है ना जो उसको क्या
ठीक है नहीं चल मैं वो गो थ्रू कर लेता हूँ ठीक है लेट मी जस्ट क्विकली गो थ्रू दैट कि व्हाट टाइप ऑफ क्वेश्चंस यू विल गेट ठीक है let me take a few A2 examples. अच्छा, you're not supposed to calculate pH. ठीक है, so one thing, let me just open some A2 papers for both of them. अच्छा, titration curves. ठीक है, remember it's going to be you have to keep things very simple because they're not going to ask you to calculate pH. So that pretty much leaves everything to A2. ठीक है, in AS it's going to be very basic. So, here's for example, here's a titration curve. What happens is if you have a strong acid in the flask, okay, so let's say you're starting, you have a very strong acid in the flask. Okay, so you've got a strong acid. So initially the pH would be very, very less. now you're not supposed to know how to calculate the pH. So आपने जो करना है, you just have to make a guess. So let's say the pH is 1 or maybe 2. ठीक है, it's a strong acid. And if you're adding a strong base from the top, any strong base, and you should have an idea of what are strong acids and what are strong bases. Strong acids are pretty much any acid that doesn't have carbon in it, any non-organic or inorganic acids. They're all kind of strong. So, I mean, that includes HCl, HNO3, H2SO4. Anything that's not got carbon in it, I mean, most of them are kind of strong. Even their details are not important. I mean, you just need to know the ones that you already know of. So these are kind of strong acids. So what are strong bases? Group 1 hydroxides, or the ones that are lower down in group 2, and even ammonium hydroxide. So these are strong bases. Group 1 hydroxides, group 2, the ones at the bottom of group 2, because the top ones are not soluble. So at the bottom of group 2, and there's ammonium hydroxide as well. These are strong bases. The other ones don't dissolve that much in water, so the pH of the water will not have a lot of OH ions. And so what's going to happen is that when you have a strong acid and you're adding the base from the top, this axis is the volume of the base that you're adding. So you're adding the base from the top. What happens is that initially if the pH is very, very low, the pH is 1. And remember, the pH does not really change much. It doesn't really change a lot, because although this is not important, I'll explain why the pH doesn't really change a lot. Patani, I don't know if a lot of you have studied log or not, but let me explain. A pH is basically a logarithmic scale. pH is basically the negative of the log of the concentration of H+1 ions. What that basically means is a log, what it does is it expresses things in the powers of 10. So for example, if something is 0.1 mole per dm cube, what is this value expressed in the powers of 10? That's 10 to the power minus 1, right? So the pH of this thing would be 1. Minus chala jayega because it's got a minus sign in front of it. So the minus goes away. If something is 0.01 mole per dm cube, so what happens? What is the pH? That's if you express this in powers of 10, that's going to be 10 raised to the power minus 2. So this will have a pH of 2. So the idea is similarly, if something has a very low concentration of H+1 ions, what is this 10 in terms of 10 raised to the power what? What is this? Ye kya hoga?
6.
So this would be, if you calculate pH, that's going to be 6. So pH, what it does is, I mean, the many ways of the many advantages of using this, because it's very easy to plot a graph that has numbers such as 1, 2, and 6. It's very hard to plot a graph that so the log graph is very helpful because it makes plotting values very easy. But it's very hard to plot 0.1, 0.01, and penta 01 on the same piece of graph paper. It's extremely hard. But when you take the log values, it becomes a really nice graph. So that's why log is preferred in a lot of cases. You can make very neat graphs out of it. But there's a problem, and the problem is that if the values over here, if the decimal places are not changing a lot, like if you go from 0.1 mole per dm cube to 0.01 mole per dm cube, that's a huge change. 90% of the H+1 has been neutralized. So, but what happens in the log graph? There's a very small change. When does the value really change? The value really changes when you go very close to 0. As the concentration of H+1 goes closer to 0, the value starts to increase. It goes to 6 all of a sudden. So start ke andar, the pH graph does not really change much. Like if you go from 0.1 to mole per dm cube to 0.01, there's hardly a change of 1 pH, although 90% of the acid has been neutralized. As if the concentration of H+1 goes even further to 0, there's going to be an even bigger jump. In this case, it's going to be what? So as the H+1 gets neutralized, the graph or the pH starts to increase. Okay, because this is 10 power what? That's 1, 2, 3, 4, 5, 6, 7, 8. I think that's 9. Okay, so the pH would be 9. So is the idea clear? Okay, why is the graph moving in that way? I mean, this is not important, but is the idea clear that initially the graph does not move much? As soon as you hit the neutralization point, that is when the graph, when the H+1 concentration almost goes to 0, that is when the pH graph really starts to, its value really starts to increase. Okay? Is that point clear? You clear, Kenny?
Yes, sir.
Achha, so the idea is that when you have a strong acid in the flask, initially the pH is very low, and the pH doesn't really change much. You're adding a base, the base is coming down, it's falling onto the acid, and the acid is getting neutralized. There's going to be a point at which the acid gets completely neutralized. Okay, that's known as the equivalence point. Like if you had 10 moles of acid and you added 10 moles of the base from the top, that means that all the acid has been neutralized, assuming that they're reacting in 1:1. Let's assume that they're reacting in 1:1. So that is the equivalence point where the pH crosses pH 7. So that's known as the equivalence point. That indicates that the acid concentration is now almost close to 0. And a certain amount of volume of base needs to be added to reach that equivalence point. And if you don't stop over there, and after you've neutralized all the acid, you continue to add the strong base from the top, what will eventually happen is that the solution at the bottom will become more and more basic. And since it's a strong base, the pH will continue to increase until it reaches, I mean, strong base ka pH kya hota hai? That's close to 14, right? So it eventually reaches 14 or something. Now, most of the questions would be about the shape of the graph. The shape of the graph is, just remember, there's going to be, at the equivalence point, there's going to be a vertical straight line. So I'll give you an example. And the other thing is, the only difference that they're going to do is that instead of a strong acid, you might have a weak acid. The shape of the graph would exactly be the same, except that the starting point would be for a weak acid, which would probably start at 4 or 5. It will, so initially the pH would be around 4 or 5, and then it will get neutralized. And then when you add this strong base in excess, then the solution will become more and more basic eventually. And vice versa. So you'll have 4 different types of graphs. Okay, if I have, let's say I have a strong base over here, or let's say I have a weak base, and I am adding a strong acid from the top. So what is the expected shape of the graph? It's going to be that you're adding the strong acid, so the volume of the acid is on this axis. On the other axis, you're measuring the pH of the solution. So initially it's a weak base. So the pH might start at, what's a weak base? That's starting pH would be around 9. And when you start pouring the acid, the base would eventually start to get neutralized. There would come a point, which is the equivalence point, where all the base gets neutralized. And that's when, since you're adding a strong acid, when the acid goes in excess, it will become, the solution would eventually become strongly acidic. So the final pH would be around somewhere around 1. And that's the equivalence point. That's the point where you should have stopped. You should have stopped adding the strong acid from the top, because all the base at the bottom has been neutralized. Uske baad jitna bhi dal rahe ho, that's going in excess. So that is the point where you should have stopped. And you can calculate the volume of the acid that is needed to reach the equivalence point. So for example, so that's one thing. You should know what the shape of the graph would actually look like. So I'll do a couple of questions. So you might get a moles question like the one that's over here. For example, you might get a question similar to this one. Okay, in this question, they're saying, I mean, this is a possibility. I mean, this is an A2 question, but it is possible you might get this question. So it's like a moles question. So there's an acid and there's a base that's being added to it. They're saying when 25 cm³ of the sample of dilute sulfuric acid was titrated. So let me rub this off first and we'll try and solve this question. Just a second.
So when will you do our paper?
नहीं पहले ये कर लेते हैं, थोड़ा इम्पोर्टेंस की बात कर लेते हैं.
ये A2 का नहीं है?
नहीं ये AS का है जो अब AS में आ गया.
Oh, okay.
वो problem is कि the only questions that you have are from A2, right?
Then
So-
can you send like a topical worksheet maybe of these questions, because I don't
Nee,
see
the pro-
them in
the
any
problem
past
with the-
papers.
The problem with these questions is कि I mean A2 it's way more complicated, so you can just do like 2% of the question. I mean your part of the AS exam that's coming in your AS exam is very simple. I'm just saying that, I mean, this is a good example that a question like this might come. You just need to understand what this curve means. This means that this is the point where the solution is getting neutralized. Okay. So
All right.
I've got sulfuric acid. That's the sulfuric acid at the bottom. That's why. How did I know that the sulfuric acid is at the bottom? Because initially the pH is strongly acidic. Okay. And there's guanidine, which is some base, which I have no idea what that is, but it's called B, and that base B is being added from the top. How do I know it's being added from the top? That when we are adding it, the acid gets neutralized. And eventually, when the base is in excess, the solution becomes very, very basic. As a fellow talk, by looking at it, what's the ratio of the acid to the base? Like in what mole ratio would they react?
1:2.
Okay, because sulfuric acid produces 2 H plus 1 ions, while the base accepts 1 H plus 1 ion. So there should be 2 base molecules, right? So one sulfuric acid would produce 2 H plus 1, and 2 of the bases will have to accept 2 H plus 1. So it's 2 bases versus, I mean, that's the ratio, 2:1. Achha, question is, first thing, is guanidine a strong or a weak base? So you might get a question like this. So what kind of a base is this, strong or weak? I think that's obviously strong. It's around 14. 14 se bhi zyada lag raha hai, theek hai? So it's about 14. So it's a strong base. Explain your answer. The pH is 14. That's it. Calculating pH, that's not in your course. Now he's saying calculate the concentration of guanidine in the solution in mole per dm cube. So this is the question that you might get. You might get a moles question on this. You even got questions similar to this in O levels as well. Achha, kitna volume of guanidine was added so that the acid got neutralized? I mean, this is the neutralization point. So what is this volume? That's roughly laga dete hain. You should use I'll just take that as 35 cm cube. Okay. So that means 35 cm cube of guanidine was needed to neutralize how much sulfuric acid in the flask? There was 25 cm cube sample of sulfuric acid at the bottom. Okay. Or did they give any concentrations? Did they tell us any concentration? It's not mentioned over here. It's not really mentioned. Why? So just a second. I'll make up one because I mean, this calculation, the pH calculation is not part of your course. So I'll just say that maybe they've told us that sulfuric acid is 0.15 mole per dm cube. You can remember the pH calculation. I mean, that's why I can't send these questions because, so let's assume that the sulfuric acid has a concentration of 0.15 mole per dm cube. So now it's a moles question. You've figured out the neutralization point. How many moles is this? 25 into 0.15 divided by 1000. कितना आ रही है? Mikhail Saim, you here?
Sir, 0.00375.
So you're getting 0.00?
375.
375 moles, right? So now you already know from this that the ratio of sulfuric acid to the base is 2:1. So the amount of base must be double that, right? For equivalence. or for neutralization. So usko double color, you'll get the moles of the base. So what is 0.00375 into 2?
0.0075.
This is 0.0075 moles. And now you can find the concentration because you know the volume that's being added of the base for equivalence. So how do you find concentration? Concentration is moles over. So 0.0075 divided by 35 cm cube in dm cube. So that's TK, and you'll get your answer, TK. So the purpose of this question is, remember the importance of the equivalence point. That's the neutralization point. Like when you do a titration, now a lot of you have done titration in labs. So that's the point where you should have stopped the titration. Okay, that's the point when the acid at the bottom has been completely neutralized. Zyada daloge, the solution would become more basic. So you might get a question similar to this. And then there's other types of questions that you might get. For example, pisla clear hai ye wala?
Yes, sir.
So there are other types of questions where they might ask you to sketch a pH curve. Just a second, let me. And remember, they're going to ask you to sketch it. For example, over here, they're saying that. So they're saying that G is this thing, and it's titrated with HCl. So when something is titrated, so G is at the bottom, G is the base, and it's titrated with HCl. That's the first line of the question. Okay, so they're saying G is being titrated with HCl, and two successive acid-base reactions take place. And write equations for the two acid. That's a bit. That is probably not going to be coming. Leave that. Let me just find another one. Yeah.
So how are we supposed to practice on these questions?
I mean, just this. It's simple. That this one. Let's do this one. You're given this one is a proper question that you might get. So, anyways, is it a strong base or a weak base?
Strong.
Okay, that's a carboxylic acid. So that's a weak acid, right? So you're being asked to sketch a pH curve, right? So how would you do that? So NaOH is added gradually. So what's at the bottom? At the bottom in the flask, there's the carboxylic acid. And NaOH from the top is being added gradually. So top se NaOH aa raha hai. So first thing, how much? 20 cm cube or 0.1 mole per dm cube. So you're adding 20 cm cube of 0.1 mole per dm cube. And at the bottom, it's gradually added to 10 cm cube or 0.1 mole per dm cube of this. So you have 10 cm cube of 0.1 mole per dm cube. That's in the flask, and you have to sketch the curve. First thing, starting pH, you've got a carboxylic acid. What do you think when no NaOH was added? Volume of NaOH is 0. What do you think is going to be the pH? Like, you just have to make a guess.
4.5.
Take a 4.5 color. So it's let's take 4.5. Let's say that's your starting pH. So remember, you don't know how to calculate pH. That will be studied in A2. So otherwise, I mean, might be mentioned in the question, but over here it's not mentioned. So let's take that as 4.5. That's my starting pH. As a first thing, when will the acid over here get completely neutralized? Like, how many moles of the acid do we have to begin with? What's 10 into 0.1 divided by 1000? That's 1 into 10 to the minus 3 moles, right?
Yes.
You got 1 into 10 to the minus 3 moles, and it's a weak acid. In what ratio do they react? Carboxylic acid and NaOH. They're going to react in 1:1, right? I mean, you should know the equation as well. That's it's going to form a salt, and it's going to form a water molecule as well. As anyways, it's 1:1. So that means for this acid to get neutralized, the same amount of NaOH must be added. So it should be 1 into 10⁻³ moles. So how much volume should I add? I mean, ignore the 20 cm³. I mean, in total, they're adding 20 cm³. Tell me at what volume will you have equivalence? Okay, so that means you don't actually need 20 cm³. You just need 10 cm³, right? Because if you add 10 cm³ from the top, volume into concentration 10 into 0.1 would give you this, right? So the equivalence will happen at 10 cm³. So that means the solution will reach a pH 7 or will be crossing pH 7 at somewhere around 10 cm³. Is this point clear?
Yes, sir.
Okay, but now the problem is that you're not adding 10 cm³. So when you've just added 10 cm³, the solution will become neutral. But you're adding in total 20 cm³. So that means when you add 20 cm³, you are adding a lot of excess NaOH. That is not required. After 10 cm³, the carboxylic acid would be gone. It would all be neutralized. After 10 cm³, the rest of the 20 cm³, after 10 up till 20, all that NaOH that's being added is in excess. So what would be the final pH? The solution will have a lot of excess NaOH. Okay, so it's going to be strongly basic, right? Is that clear?
Yes, sir.
So that's how you're going to sketch it. You've got these 3 points. And you have to figure out where would equivalence happen. Like when should at what volume will the solution in the flask will be neutralized, right? That's what you're looking for. You have to guess what the starting pH is, what the final pH is, and then you're going to make the curve, which is okay. The majority pH change will happen around it's going to happen around the equivalence point. Okay, that's where the majority of the pH change will happen. Or it's just going to be a very gradual change. And even after that, it's going to be it's going to be S-shaped. So that's how probably the sketch would look like. Okay. Is this clear?
Yes.
Yes. I have a question.
Yes.
Sir, why did we use methanoic acid when the acid is different in the question?
Yeah, I'm not using methanoic acid. I'm just using R. Like R means rest of the molecule. It's a carboxylic acid. It's a chloroethanoic acid. I'm just ignoring that because that's not relevant to the question. So I just wrote R instead. R just means rest of the molecule. Okay.
Okay, sir.
Achha, so this is one question that you might, and in the latest one you have one question. Okay, we'll go through that as well. Then there would be questions about indicators. Let's focus on the same question. Now, when you add an indicator, why do you add indicators in titration? Because you want to stop at this point, right? That's the point where you should have stopped. I mean, because after that, you're just adding too much NaOH. That's not required. So how do you stop at that point? You stop by adding indicators. And the suitable indicators are the ones that change color around the equivalence point. Like if you have this equivalence point, the best indicators are the ones that are going to change pH within this pH range. Because you want the color to change over here. For example, if an indicator changes color at pH 8, then as soon as the solution pH crosses 8, it's going to change color. So you're going to stop right at 10. You don't want an indicator that changes color at this pH, because if it changes color at this point, then that's not the equivalence point. Or after that, you want the indicator to change color within this range. So they might ask you to select suitable indicators. And you don't really have to remember all indicators. Pretty much the syllabus doesn't really talk about indicators. It just is asking you to know how to select a suitable indicator. They might give you a table, but for 2, I think you should remember, because they're so common that, especially in titrations in the lab, remember about methyl orange that it changes color at between 3 and 4. Before lower than 3, the pH, if the pH is lower than 3, it's red, and above that it's orange yellow. And there's another one which is phenolphthalein. As a phenolphthalein is colorless initially in acidic, and around 8 to 9 it changes color, and after that it's going to be purple. अच्छा, तो इस केस में मुझे बताओ, which indicator would you prefer, methyl orange or phenolphthalein? Which one?
Phenolphthalein.
Take phenolphthalein, because 8 to 9 that's over here. 3 to 4 is probably, I mean, the solution never actually reaches 3 to 4, so it's never going to change color, specifically for this one. So the curve, the pH curve never actually touches 3-4, but it was starting at 4.5, so it never actually crosses that point. So it's never going to change color. So in this case, so that could be another question. And let me just see if there are other similar types of questions. We run out of questions. Oh, we've got a question on indicators over here. Achha, here's another one. HCl. Okay, so this one. Let's try this one. Try this one. Achha, ammonia first thing. Is it a strong base or a weak base?
Weak base.
Okay, remember also that all nitrogen related bases are all weak bases. So that's a weak base. I mean, the only strong bases were those that I mentioned earlier, which included group 1 hydroxides, the ones at the bottom of group 2 hydroxides, and ammonium hydroxide. Those are the only ones that are strong bases. I say ammonia is a weak base, and so this ammonia, which is what? I said ammonia is 20 cm cube of 0.2 mole per dm cube. Isko zara find the moles. How many moles is this?
0.0004.
Okay, 20 into 2 into 10 to minus 3. Nee, 4 into 10 to minus 3, right?
Yes.
So 4 into 10 to minus 3 moles, volume into concentration. So you've got this ammonia, it's a weak base. What pH would it have initially?
10 or 11.
10 कर दें.
ठीक है, 10 ठीक है. Let's make it 10. Like it's going to be far away from 14. 8, 9, 10, that's fine. So let's take 10. So the starting pH is 10 when you haven't added any acid. What you are adding from the top is a strong acid, which is HCl. So you're adding HCl from the top, and it's 0.1 mole per dm cube. And they haven't told us over here in the question, they haven't told us how much we are adding. Like the axis goes up till 60 cm cube. So in total, you're adding 60 cm cube of the acid. Yeah, that's the total amount of acid that is being added. You can tell me what is the amount of acid that would be, what is the ratio first? HCl and NH3, that's 1:1, right? Achha, so tell me the volume of, I mean, ignore 60 cm cube because 60 cm cube I think is too much. Tell me how much HCl from the top, volume of HCl needs to be added. So you get 4 into 10 to the minus 3 moles. What should the concentration be multiplied with? 40 cm cube, I guess, for equivalence. I mean, if you have 4 into 10 to the minus 3 moles at the bottom, there should be 4 into 10 to the minus. Okay, so I guess 40 cm cube would result in equivalence. That means at 40 cm cube, if you add 40 cm cube, all the NH3 will react and the solution will get neutralized. So at 40, you'll have equivalence, which is that the pH curve would be crossing 7, right? Because all the ammonia will be neutralized. But in total, you're adding 60 cm cube of the acid. So that means 20 excess acid is being added. So when you add the excess 20, there's nothing to react with. So there's going to be strong HCl present over here. And what is the pH of the excess HCl?
1
Okay,
or 2.
take a 1 or 2 or 1.5 or something. Okay. So you've figured out 3 points: the starting pH, the middle part, and the final pH. And again, make the curve. Remember, mostly the pH will change around the. It's going to be almost a vertical line, and gradually after that, okay, so it's going to be something like this, and that's going to be that's your sketch. And what indicator do you think are suitable in this case?
Methyl orange.
In this case, I think it's methyl orange because your 3 to 4 would be somewhere, because phenolphthalein changes pH at 8 or 9. So that might come over here at this point. So you want the color change to happen when the pH changes at this point. Okay, is this clear?
Yes, sir.
So I mean, that's the toughest question. I'll also discuss. I'll take out the latest one. There were 2 questions in the 2022 paper. Just 1 second. Give me 1 second. किसी ने भेजा था मुझे, just 1 second. Just 1 second. So this one. So this one is the latest one, 2022. So this one had a question on that's says you had this one. They were saying that what is meant by this by a strong Bronsted-Lowry acid, that's acid is proton donor, strong means that it fully ionizes. So 2 marks. And then they're saying sketch the pH titration curve produced when 0.1 mole of mole per dm cube of NOH is added gradually to 25 cm cube or 0.1 mole per dm cube HBr to excess. So they're adding NOH from the top. I mean, this is one thing that you should decide, like what is happening, what's being added. So NOH is being added to what? To HBr. Okay, so it's being added to HBr, which remember is a strong acid. But maybe they maybe in the question, did they mention? Just remember, group 7 halides are all strong acids. But coming back to this, the question did not have any information on that. Now, it's being added to HBr. And what's happening is the concentration of NOH is 0.1 mole per dm cube. And the concentration and the volume of HBr, that's 25 cm cube of what? Of 0.1 mole per dm cube. So how many moles is this? This is what? 2.5 times 10 power minus 3. You get that, that's. Is this 2.5 times 10 power minus 3 moles?
Yes,
Yes,
sir.
sir.
Sir. So what are you going to do? You're going to add the same amount of for equivalence for neutralization. The volume, I mean, remember, look at the y-axis over here. The total volume that he's adding is 45 cm3 of NaOH. But what is the volume that is needed for complete equivalence? NaOH and HBr will react in 1:1.
25.
Okay, so that's going to be 25 cm3 because if it's 1:1, 2.5 times 10 per minus 3 moles, there should be 2.5 times 10 per minus 3 moles that must be added from the top. So that means your equivalence is happening at 25 cm3. At 25 cm3, the pH would be around 7, right? Starting pH kya hoga? That's strongly acidic. So I'm going to take that as 2. Okay, that's my starting pH. What is the final pH? Once I've added 25 cm3, all the HBr is gone. And after that, any extra NaOH that I add, that's in excess. So if that's in excess, that means it's going to be strongly basic. So it would be around 14. So the maximum pH change will be happening around the equivalence point. And after that, there's going to be gradual change. I mean, make it slightly curved. This other one is calculation wise, it looks exactly the same. It's the same, it's 1:1. It's the same concentration, same volume. So calculation wise, it's exactly the same. Again, NH3 is being added to HBr. So the only difference is that instead of NaOH, you're adding NH3 to it. So when you're adding NH3 to it, NH3 is a weak base. So initially it will be strongly acidic. The equivalence will also happen at the same point. So it will be crossing pH 7 somewhere over here. But at the end of the day, it's not going to be that basic. It's when 45 cm3 is added, when excess ammonia is added, it's not going to be that basic. It would be around 10. So that's the only difference. And you'll just that's how this curve would look like. Is that clear?
Yes.
Sir,
Yes.
could you repeat the last part? Why isn't the pH 14?
Yeah, because you're adding in the second titration, you're adding NH3.
Oh,
So
okay.
I mean, so the only difference is, I mean, in both graphs would be exactly the same because you're using the same concentration, the same volume of HBr, everything is the same. So the equivalence, everything would happen. It's and both reactions are 1:1. So everything is exactly the same, except for the fact that when NH3 goes in excess, when you add too much of it, the solution will not turn that basic. It won't turn strongly basic. It will turn weakly basic. Okay. Or so that's about it. And if they give you some information over here, I think you can use any indicator in a strong acid, strong base titration. The vertical part is so big that pretty much all indicators work. Depending, I mean, that information would be given to you. But over here, you can't use phenolphthalein, at least, because it changes pH at around 9. So it won't exactly change over here. Methyl orange would work 3 to 4. That would come in this range. So let's start with a paper. We're done with examples of this question, the type of questions you might get. So we were supposed to do this paper. I'll start.
So when are we supposed to do October, November 21? Like variant 21.
वो करना है ये वाला करना है
21 करने बेहतर है
21 कर लेते हैं अच्छा 21 starting with the first thing what does volatile mean what's volatile
a substance which evaporates easily at low temperatures
ठीक है so it's got low boiling points and it evaporates easily at RTP I said draw the dot and cross diagram of CS2 that's sulfur is in the same group as oxygen, so our carbon will form double bonds with sulfur, and sulfur has 6 electrons, so 2 are bonding, so 4 electrons left. So it's the same as carbon dioxide. So what is the bond angle over here?
180.
Okay, that's 180 because you got carbon in the middle. Okay, the middle one is the one that decides what the angles are. So in this case, the middle one decides what the angle is. In this case, it's going to be 180 degrees because you got 2 pairs of bonds and it's linear. CS2 is a liquid. Under room condition, CO2 is a gas. First thing, explain what causes the difference in the physical properties. First thing, do they have dipoles or not? Like, I mean, they're talking about the physical difference. Specifically, one is a liquid, the other one is a gas. So the question, do they have permanent dipoles?
Not permanent.
They don't have permanent dipoles because the dipoles get cancelled out because of the shape. It's linear. So this oxygen is pulling electrons in this direction. This oxygen is pulling electrons in this direction. The both forces of attraction will get cancelled out. The electrons would remain equally distributed. So they won't go to one side. So you got, so that's the non-polar. So they're non-polar. So what type of forces do they have? They've got van der Waals forces, which is basically temporary dipole or instantaneous dipole. In the recent marking schemes, they've started using the word instantaneous dipole, induced dipole, but doesn't make a difference. Induced dipole, attractive forces. So that's probably going to give you 1 mark. So which one has more instantaneous dipole, induced dipole, attractive forces? Or van der Waals? What factors does van der Waals forces depend on?
CS2.
Okay, because it's bigger in size. Okay, it's bigger molecule, it's got more electrons. So there's going to be more fluctuation happening. Sometimes electrons would be on this side. So that side would become strongly negative. This side would become strongly positive. If it interacts or collides with another molecule, maybe the electrons slightly shift to this side. So the greater the number of electrons, the more van der Waals forces you're going to have. So it was just 2 marks. You're going to just state that they both have van der Waals forces or instantaneous dipoles. And the bigger molecule has more electrons. So there's going to be more van der Waals forces, which is why it's a liquid, while the other one is a gas. Let's define the enthalpy change of combustion. So energy released. Remember the definitions. I'll send a worksheet on. I'll send a sheet on definitions as well. So it's energy released when what happens when 1 mole of a substance burns in excess oxygen. Burns in excess O2. Measured under standard conditions. Now you've got this question. They're asking, use the data in the table to calculate the enthalpy change of combustion of CS2. So first thing is I'm going to write the equation. I've got CS2. I'm going to burn it in excess oxygen. What are my products going to be?
Carbon dioxide. Carbon dioxide and sulfur dioxide.
Remember sulfur, when you burn sulfur, you don't get sulfur trioxide, you get sulfur dioxide. Making sulfur trioxide is a lot harder, and you're going to balance this. It's 2 sulfur dioxides, and that would give you 3 O2. So that's your balanced equation. Now, the other thing is the information that's given is you're given the enthalpy of formation of CS2. You're given the enthalpy of formation of carbon dioxide as well. And you're given the enthalpy of formation of SO2 as well. in the table over here. What's the enthalpy of formation of O2?
0.
Okay, that's 0. So basically, you know that as well. That's 0. What formula would you use to find the enthalpy of this reaction?
Product
minus reactants.
Okay, so when you know the enthalpy of formation of everything, it's just enthalpy of formation of products minus the enthalpy of formation of the reactants. Be careful about moles and be careful about the sign. So the product is CO2, that's minus 394. I'm going to put the products in brackets. The other one is Ester2, that's minus 297, but it's going to be into 2. And minus the reactant, which is CS2, that's 89.7, and the other one is 0. So what do we get for this?
Minus 1077.7.
77.7.
0.7.
So isko, what would you write this as?
Minus 1080.
You're going to write this as minus 1080 kilojoules per mole. Because your accuracy was up till 3 significant figures. अच्छा लेकिन इसमें ठीक है. अच्छा, next one. What is meant by the weak acid? Acid is proton donor. Weak means it ionizes partially or weakly. Give the formula of the conjugate base of H2S. So what is the formula of the conjugate base of H2S? And they've told us that H2S is a weak acid. Like, first thing, if it's an acid, tell me an equation where it acts as an acid. What will it do?
Donate.
So it's going to lose an H plus 1 ion, right?
Yes.
So what is the other ion that's going to be produced if it loses an H plus 1 ion?
S.
It lost one H plus 1, right? So what's
So
left
HS.
is you've got HS left, and that's going to have a charge of minus 1 because the plus 1 just left. Okay, so it's going to have a charge. Now, whenever you have a weak acid or an acid, the ion that is formed is its conjugate base. Because in the reverse direction, it's going to accept an H plus 1, right? So it's acting as a base in the reverse direction. So this one is your conjugate base. You be clear?
Yes, sir.
Yes, sir.
So then you have react slowly with oxygen dissolved in water. The reaction is represented by the following equation. Explain why this is a redox reaction. So what is the oxidation state of sulfur over here?
-2.
Okay, that's -2, and on the other side it's 0. So what happened to it? It lost or gained. What did it do?
It got oxidized to 0.
Oxidized.
Okay, lost 2 electrons. You got, whenever you have to explain its redox, make sure you write, okay, the gaining electrons or losing electrons. I mean, that part is fine that you're writing it's getting oxidized. Why is it getting oxidized? Because it lost 2 electrons. And what's happening to oxygen? Oxygen is 0. Initially, now it's -2. So that means that it gained 2 electrons. Okay, so always refer to the 2 electrons when you have to explain it's a redox reaction. So moving on, you've got this question. It's there's this reaction. It's a moles question. A2S3, it's heated in the air. So this is happening. A sample of this is 0. So this says 0.198 grams, right? So I'm going to find the moles anyways. How many moles is this? Like there's not sure what AS is. Can somebody tell me what's the AR of AS?
It says 74.9.
And remember, make sure that This one. So AS is 74.9, right? So that's 74 point. That's 74.9. So 74.9 into, where did it go? This one. So 74.9.
So the moles are 8.0446 times 10 to the power of -4.
Sulfur को 32.1 लिया
Yes.
into 3, ठीक है? अच्छा, so what are you getting is, what are you getting? How many moles?
8.046 times 10 to the power of -4.
Into 10 is power?
-4.
ठीक है. अच्छा, again, remember that while writing it, you can round it off, but don't round off values on your calculator, ठीक है? Make sure. Now he's saying that it's placed in 0.1 dmq of pure oxygen in excess. In a reaction chamber connected to a gas syringe at room temperature, the reactants are heated until no further change is observed. The products are then cooled. Calculate the in volume in dmq of gas present in the end of the experiment. Now, oxygen is in excess. 2:9. Can you figure out the moles of oxygen that actually get used up? Because it's in excess. So what's 2:9? 8.046 into 10 to the minus 4 divided by 2 into 9. What do you get?
3.62 into 10 to the power -3.
So it's into 10 to the power -3.
3.
So I get a different thing.
मतलब क्या करना है? 2:9. That's this divided by 2 into 9. Or this into 4.5. You check color double
Okay,
check.
no,
Is
no,
this?
it's the same. Yeah, same.
That's the same. Okay, so remember he's asking about the volume of gas present at there. So we're only focusing. I'm not interested in the solid. What is this other gas? What amount of gas is going to be produced? Same thing. This divided by 2 into 6. What do you get? This divided by 2 into 6.
2.41 times 10 to the power of -3.
-3 moles, right? So here you got these many moles.
Yes.
So now the other thing is, so you found these moles. Now the other thing is calculate the volume in dmq of gas present. First thing, this thing is produced. This is the SO2 that's the gas that is produced. So how much gas is produced? How do you figure out the volume of the gas? That's moles into 24 dm3. And they're talking about room temperature, right? So that's 24 dm3. So what do you get for that?
0.058
dm3, right? So what about this one? That's the amount of gas that is produced. Like, he's not asking about the gas that is produced. He's not asking about this. What he's asking about is the fact, the total, calculate the volume of gas that is present. So what other gas would be present? This is the amount of gas that would have reacted. So can you tell what is the volume of gas, of oxygen gas, that has actually reacted? So that's going to be 3.62 times 10 to the power -3 into 24. What do you get for this?
0.087.
That's 0.087 dm3. So how much actually did you add oxygen? That's 0.1 dm3 of pure oxygen in excess was added, but only 0.087 dm3 is reacting. So that means out of the 0.100 dm3, 0.087 dm3 react. So what's the leftover O2? What's the oxygen gas that is left at the end? So try and
0.0131.
0.01?
31.
1 dm3. So this is the amount of gas that has been produced, and this is the amount of gas that is still left. So the final volume is going to be the sum of the two. There's going to be some gas that's produced, and there's some gas that's still left at the end. So it's going to be 0.058. I'm not satisfied with these values. Remember to keep the value, everything over here was given up till 3 significant figures. So make sure even when you write answers, there should not be 0.058. There should be up till 3 significant figures. So in dono ko total karo, that's going to be 0.058 plus 0.0131. So what's the total that you're getting?
0.0711.
0.0711. That's a 711 dm cube. I'll just quickly check what the Markin scheme answer for this is. ये कौन सा part था? So they're giving we're getting 711, right?
Yes.
So our rounds to 0.071. Is it rounding off to 0.071? Which I think it is.
Yes.
Rounds to 0.071.
Then they have taken 2 significant figures.
Then they just answer to minimum 2 significant figures. The proper one would have been 3 significant figures. I mean, they're accepting a minimum of 2 significant figures. What they will not accept is 4 significant figures in this case, because if your original value is accurate up till 3 significant figures, so the answer should not have an accuracy that's greater than that. Is that clear?
Yes.
And somewhere down the line, I think there was some rounding error as well, because and even when you're writing it, write it up till the appropriate significant figures. If it's 0.058, even if there's a 0 coming after that, make sure you put a 0 over there. So what does SO2 do? What's the consequence of releasing SO2?
Acid.
Okay. SO2 can be removed with NaOH. What's the reaction of NaOH with SO2? Like what is going to be produced?
Na2SO3.
Okay, just remember, okay, whenever you see SO2, think of it as sulfurous acid. I mean, just think of it as sulfurous acid. So the salt that's going to be produced is sodium sulfide, and H2O would be produced. Okay, if you have SO3, think of it as H2SO4. Now, Na2SO3 would be produced. You've got this reaction. Identify. So reaction 1, calcium reacts with nitric acid. So what is the other product that's produced in reaction 1? Metal plus acid produces salt and what?
Hydrogen.
Okay, that's H2 gas. Then calcium nitrate reacts with NaOH and calcium hydroxide is produced. Construct the equation for the thermal decomposition of nitrate. So that's this one, thermal decomposition. So what is going to be produced? It's going to be calcium oxide.
Nitrogen dioxide and oxygen.
And oxygen. 2NO2 and half O2, or you just double everything up. State the trend in thermal. So group 2 nitrates, do they become more stable or less stable down the group?
Less.
They become more stable.
Okay.
Remember this, that they become a lot more stable. उसके अंदर दिया हुआ है, एक सेकंड यहाँ पे. Let me open inorganic just a second. And I'll also explain why they become less stable. They become more stable, sorry. And you have to remember some little details about that as well, that which ones, the top two will decompose in a Bunsen flame, the bottom ones will not. So where is group 2? This is group 2. Okay. So the decomposition temperatures are provided for the carbonates. Okay, the thermal stability of carbonate, it increases down the group. They become more and more stable. Remember that a Bunsen burner, I mean, there have been questions, especially MCQ questions, not paper 2 questions as such, but a lot of MCQ questions. Remember, the Bunsen burner on average has a temperature of around 900 to 1000. So it would decompose calcium carbonate, it will decompose magnesium carbonate, but it would be very hard to decompose strontium and barium carbonate in a Bunsen flame. Nitrates are slightly easier to decompose. They will decompose at lower temperatures. So you can use a Bunsen burner for them. But again, it becomes harder to decompose down the group. And the reason for that is that, that if you have a smaller ion, the smaller ion has such a large or strong attraction. It's got a stronger positive charge density that it attracts the electrons very, very strongly. The carbonate ion, which is CO3 minus 2, it gets polarized. The oxygen gets very strongly attracted to the magnesium. And its electrons get so strongly attracted that the electrons over here, they get attracted to magnesium on the other side. So the bond over here breaks, and that results in the formation of carbon dioxide and MgO. So smaller ions have very strong positive attraction or charge density, which is why the ion becomes, the carbonate ion or the nitrate ion, it becomes very unstable. State the trend, so down the group it increases. In reaction 3, excess CO2 is bubbled through water containing calcium carbonate. A solution of this is formed. Construct an equation for this. So I think he's talking about this one. So he's saying that you had calcium carbonate and water, and there's carbon dioxide that's bubbled through it, and you get calcium and HCO3 twice. So I guess that equation is already balanced. I think that's balanced. Describe how calcium, what is the purpose of calcium hydroxide in agriculture?
Neutralizes acidic soils.
Okay, so neutralizes acidic soil. Describe how sp hybridized orbitals are formed. So carbon has 4 electrons in its outer orbitals. Each one of them has 1 electron. So how are sp hybridized? When does sp hybridization happen? What is carbon doing when sp hybridization happens?
When it forms 2 pi bonds.
Okay, when it forms 2 pi bonds. So that means 2 of the p orbitals are not doing anything. So it's the mixing. As I remember, always use the same definition of hybridization. It's the mixing of an s and a p orbital in this case. To form 2 sp hybrid orbitals. Okay, so 2 of the orbitals, they become, instead of s and p, they become sp hybrid orbitals. This one is also called sp, this one is also called sp. So what happens is 1 electron gets pulled in one direction, 1 gets pulled in the other direction. So they become sp hybrid orbitals. While 2 of the orbitals don't do anything. So you have a p orbital and you have another p orbital on the z-axis. And they end up forming 2 pi bonds. Sketch a diagram to show how the sp can form a sigma bond. So they're just looking for an sp, 2 sp hybrid orbitals. So you're going to show 2 nucleuses. The electron is of 1 carbon is going to be pulled by the other atom. And So they're going to pull each other's electrons and eventually they would merge in the middle. So the two electrons would be stuck right in the middle. So that's just the sigma bond. Pretty much all you have to do for this question is just draw the electron density right in the middle. That's what a sigma bond actually looks like. Okay, is that clear? And
Yes, sir. So just draw the second thing you've drawn.
that's pretty much it. Do I have the marking scheme open for this? No, because they were asking about how this is happening. So you're going to label two sp hybrid orbitals and then they would merge. Right? Is that clear?
Right, okay. So should you show them as overlapping or like the third thing you've shown?
I mean, because they wanted to show how this is happening. So, I mean, maybe this too would be sufficient. Tell them that the electrons are being pulled by both atoms, and which is why they're merging in the middle.
Okay, sir.
As the next part is it's calculate the minimum mass in tons of CaCN2 that is required to produce 1.56 tons, 1.5 into 10 × 6 tons of ammonia. Show your working. So the minimum mass of this thing, right? So
Yes, sir.
a pretty straightforward question. You've been given the tons of ammonia, so you can find the moles. What is moles? That's 1.5 into 10 × 6 into 10 × 6 in grams, divided by the amount of ammonia, which is 17. So that's the moles that you're getting. The moles of CN2 are going to be half of that, right? So it's going to be half into 1.5 times 10 × 6 into 10 × 6 divided by 17, right? And you have to find the mass. So you'll multiply it by the MR of this thing. What's the MR? That's 40.1. So if you want to find mass is MR multiplied by moles. And the MR in this case is 40.1 plus 12 plus 28. And into half into 1.5 into 10 × 6 divided by 17. I'm just going to get rid of 1 10 × 6 because the answer is supposed to be in tons. So क्या है इसका?
$3.5 into 10⁻⁶ tons.
3.5 into 3.50 होगा फिर. Into everything is 3 से करके 3.53
3.53
into 10⁻⁶ 10⁻⁶ tons. The next part is draw the structure of the organic product. What happens when you mix NaC and ethanolic with this? Like what does it do? What do you call the thing? एक second.
Converts to alkenes.
Nitrile.
ठीक है, it's going to form. Just a second. So it's going to form its nucleophilic substitution. It's going to form a nitrile. The Br over here. यहाँ पे दिखा भी देते हैं. अच्छा, so NaCN ethanolic. ठीक है, that's you'll just form a nitrile. That's it. The halogen will get substituted with a nitrile. So it's going to be CH3 and CH2 and CN. ठीक है, remember this I said there's always an importance for the nitrile reaction that the carbon chain length increases. What happens when you add sulfuric acid to it and reflux?
Carboxylic acid is
Okay,
formed.
so it's going to form the nitrile will get hydrolyzed to a carboxylic acid. So this thing will become CH3. And then you have NaCN
Sir,
and
it says draw, so shouldn't we draw the displayed formula?
sorry, draw the structure of the organic product. No, if they were looking for the displayed formula, then they're going to talk about the displayed formula. Okay? The structure simply means any formula that shows you structure. Structure is, when they say the word structure, it just simply means any formula that shows structure. Like it could be the condensed version, it could be the displayed version, it could also be the skeletal version. Anything that gives you information about the structure of the molecule.
So if we wrote, view the display, it would be fine.
That would be fine as well.
All right.
Okay. But remember, when they want to be specific, they will be specific. If they ask you, if they want you to draw displayed, they'll say draw displayed. If they want you to draw a skeletal, they'll ask you to draw skeletal. When they just want to show structure in any way that you want to, then it's just going to be this thing. Yeah, though they would write structural formula or just draw structure. It just means any of them, as long as the structure is shown. What would you get for this one? The ketone reacting with HCN and NaCN.
Hydroxynitrile.
Okay, so that's you've got a CH3, you got a C double bond O. So what will happen is that the CN will get attached to the carbon at the bottom. The double bond would go away and OH gets bonded to the top. So anyways, this one, you've got white phosphorus and red phosphorus both have covalent bonding, suggests the type of structure shown by white phosphorus and red phosphorus. Explain why red phosphorus has a higher melting point than white phosphorus. So first thing, the type of structure. First thing, what type of structure would this have, and what type of structure would the other one have? And when they talk about type of structure, it's basically chemical bonding that they're talking about. So white phosphorus, what type of structure would they have? It's going to be it's going to have covalent bonds, but it's going to be simple molecular. What about the other one?
Ions or giant.
Remember, that will also be covalent because phosphorus always forms covalent bonds.
Alright, the giant.
But that's going to be a giant covalent or a macromolecular structure. These two are also given in the notes over here as well, which is that one of them is giant covalent. Let me just show you. I said this over here. Okay, what happens is that the white phosphorus is a simple molecule. It's just 4 phosphorus atoms that are connected to each other, each phosphorus atom making 3 bonds. But what happens is that red phosphorus is formed when it polymerizes. How does it polymerize? That the bonds that were between them, that's white phosphorus. The bonds between the phosphorus atoms, they break and they start connecting with the neighboring one. And they end up forming a macromolecular structure. They form a polymer-like structure. So this one is the polymeric form of red phosphorus is the polymeric form of white phosphorus. So the question is about that. They're not going to be that specific. So we did talk about the structure. And the explanation for the high melting or low melting point is that over there you have to break weak intermolecular forces. Like if I come back to this, in P4, there's one molecule and there's another molecule. They just have weak intermolecular forces between them. But when you have a red phosphorus, it's a polymeric form. So you would have to actually break bonds in that case. Okay, so in a giant covalent structure, you're breaking bonds, while in simple molecular structures, you're just breaking weak intermolecular forces, which in this case are van der Waals forces. Is that clear?
Yes, sir.
Which could you explain that again, please?
वही है ना कि कहाँ गया इसका भी वैसे देख लेते हैं वही तो I'll explain ठीक है just a second. See, this is sorry अच्छा this is white phosphorus, right? P4. So in P4
Yes.
you've got one molecule and you've got another molecule, right? But they don't have anything to do with each other, right? There's no bond between them. Is that clear?
Yes, sir.
So what do they have between them? What's the attractive force between them? That's a weak van der Waals forces, right?
Yes.
So that's a weak intermolecular force. But when you have red
All right.
phosphorus, in red phosphorus, it's a polymeric form where the bonds between them break and they start connecting with each other. Now, if I want to melt this, they're all connected to each other. So I would have to break the bonds, right? So
Yes, sir.
when I need to melt or boil a P4, I don't have to break the bonds. I just have to break the intermolecular forces. But in a giant structure, I would have to break the covalent bonds. So yeah.
All right. Okay.
So next one is you just have to sketch this. It's an exothermic reaction, so the product is going to be lower. That's your P solid, and this is going to be delta H, and that's going to be your activation energy. You can write the value over here as well. That's minus 17.6. As a moving on, you've got P4, PCl5, and so on. State the oxidation number of phosphorus and P4O10. So what's the oxidation number over
Plus
here?
3.
That's plus 3. Are you sure?
It's plus 5.
It's
Plus
4x and minus 2 times 10, and the whole thing equals 0. So it would be x would be 20 divided by 4. That
4.
comes out to be plus 5. I said now you have a reaction of what happens when PCl5 is mixed with water.
HCl and H3PO4.
Okay, so you get HCl plus H3PO4. And there's going to be 5 HCls, I guess, and that's 8 H's, right? So 4 H2Os. The next one, P4O10, when you mix it with water, what happens? What kind of acid is formed when P4O10 mixes with water?
Only H3PO4.
Because only H3PO4 will be formed, and there would be 4 of them, and there would be 16 oxygens, so 6 H2Os, I guess. To either recall bhi kar lete hain ki you have to remember in period 3. Where's period 3? Remember this first thing. As if they had given you P4O6, remember one thing, that P4O10 and P2O5 are the same thing. Similarly, P4O6 and P2O3 are the same thing. So if you mix P4O10 with water, you get phosphoric acid. If you mix P4O6 with water, you'll get phosphorus acid. Same goes for sulfur dioxide and sulfur trioxide as well. Similarly, if you mix PCl5 with water, which is an unstable white solid, you'll get H3PO4 and HCl. If you mix PCl3, on the other hand, you'll get H3PO3, not H3PO4. Okay, so memorize what happens when chlorides are mixed with water and when oxides are mixed with water. So now give the empirical formula of triphenylphosphine. Now they've already told you that this is C6H5. This entire thing is C6. So that's kind of easy. It's C6H5. That's another C6H5. That's another. So that's C18. And how many H's? That's 5, 5, 5, that's 15. And you've got one P. So I guess that is the empirical formula, right?
Yes, sir.
As a next one, you've got an aldehyde, right?
Sir, अगर आप P पहले लिख दें, it's fine, right?
That's fine because it doesn't really matter in this case. The molecular formula, it doesn't really matter. Okay, what's the order of the atoms, right?
Yes.
So in a Wittig reaction, an aldehyde reacts with a halogen alkane to form an alkene. The conversion is shown in the following unbalanced equation. So what is happening in this unbalanced equation is that you have R2 replacing the oxygen at the top, right? I mean, that's what's happening. So compound H can be made from propanol. Stage 3 in the reaction scheme is a Wittig reaction. So stage 3, which is this one. So they're saying that's a Wittig reaction. State the type of reaction that occur in stage 1 and 2. So what is stage 1?
Reduction.
Okay, that's reduction. Aldehyde getting reduced by?
Alcohol.
Okay, so it's going to form an alcohol. It's this reaction over here, which is पता नहीं क्या है. ऐसे भी खोला था, कहाँ चला गया? Anyway, so that's reduction. It's going to form an alcohol. And it will become CHO will become COH. And they're going to be 2 H's. So hydrogens get added, it forms an alcohol. Then you add red phosphorus and iodine. What will happen to this? The OH will get replaced by iodine. Is that clear?
Yep.
So what are the types? The first one is reduction. Remember, he's asking for the type. So the first one is reduction. What is the second one?
Substitution.
Nucleophilic substitution.
And that's specifically nucleophilic substitution. So then you have draw the structures of G and H in the boxes. We've already drawn, again, it's structures. So anything that shows structures. So we've already drawn G and we have to draw what H is. So H is tricky now. Now this reaction, you haven't studied this one over here. You haven't studied this reaction. So by looking at this Wittig reaction, what do you think is happening here? Okay, remember the aldehyde structure would kind of remain the same. So let's start with the aldehyde. That's C, double bond O, H, and there's C2H5, right? So that's my aldehyde, right? So I'm going to compare it with this one. So what's going to happen? First thing, the oxygen from the top is going to go because I mean this thing and the product they have everything remains the same except there's double bond and then there's no oxygen on the top. So that oxygen is gone. Is that clear? And
yes, sir.
What joins it? The R2, I mean this carbon over here, the one that was connected with iodine, that is the one that joins the top, right? Is that clear as well?
Yes, sir. Yes.
So basically C2H5 joins it. I mean, not even that carbon joins it. It's the R2, the one after that. I mean, this one is CH2. So it's the I and then the CH2, it's the R2 that joins it, right? So it's I, CH2, it's C2H5 that's going to join it. So this carbon over here will have C2H5 that would be, I mean, it's going to be this part that would be joining it. So the C2H5, that's your R2. If you compare it, that's your R2 that joins it. And there's going to be one H over here as well. Because that's going to be my product. Is that clear?
Sir, why did
Yes,
we
sir.
add another H?
Yeah, because the bonds were not. I mean, there's an H over here. It's just they had drawn a skeletal formula. I mean, carbon over here is making 3 bonds.
Okay, sir.
So I'm drawing the structural formula with the hydrogen atoms. Okay, so you just have to do a comparison. This thing compared with this one, and you figure out what the product is going to be. I said, now you've got hot concentrated KMnO4 acidified. What will happen? Strong oxidation. What happens in strong oxidation? The double bond breaks, right? What will happen to this carbon atom?
CO2 and H2.
If you
Ketone.
it's not going to be carboxylic acid. It's this one. So it's this one. The double bond will break when you have strong oxidation, hot concentrated KMnO4. And if it's got 1 carbon chain, it turns into carboxylic acid. If it's got 2 hydrogens, it changes into carbon dioxide. 2 carbon chains, that will turn into ketone. So this one over here will, the one on this side, that's this, and 1 carbon atom, right? So this particular, and I'm talking about this carbon atom, this will turn into carboxylic acid.
So right side has 2 R groups, right?
That's 2 R groups. So what will that turn into?
Ketone.
Okay, so that will turn into a ketone. So he's not asking you to draw the structure, he's asking you to identify the organic product. So what would you call this and this? I mean, the question is vague, so we're not sure whether he's asking for the structure or the name. So we're going to do both. So what's the name of this
So
one?
mark scheme देख ले.
नहीं, लेकिन वो देख लेंगे, लेकिन जब नहीं पता तो फिर दोनों कर दो ना.
Right, okay.
So because we don't know what does identify mean over here. Are you?
Carbonyl group.
Nee, what's the name of this thing?
Propanoic acid.
Propanoic acid.
Okay, so this one is propanoic acid, and that one is
Propanone.
propanone. Because that one is propanone, and the answer over here is the formula. Okay, but we did both, so that's fine. I said this one, we've got another reaction. The reaction scheme shows B can be made from ethanol. I mean, you're making B, right? So it can be made from ethanol. First thing, this is oxidation. When you have an O, that is oxidation. So what is the name of this molecule?
Oh, which one, sir?
This one.
Ethanoic acid.
Okay, that is ethanoic acid. It's 2 carbon atoms and 1 carbon atom is carboxylic acid. So that's ethanoic acid. So this is simple oxidation, a primary alcohol turning into carboxylic acid. What reagent is used to turn a primary alcohol into ethanoic acid?
Hot acidified KMnO4.
Because you can use KMnO4 or K2Cr2O7 acidified, and what conditions would you use?
Heat and reflux.
Okay, so it's going to be reflux or heat and a reflux. Heat and a reflux is the better word.
So you can use K2Cr2O7, right?
Yeah, I mean you can
Sure,
use.
And so the acidic, should we write it in the conditions or like with the reagent? Just
I mean that's a
acidic.
condition. That's a condition.
No.
The preferred one is K2Cr2O7. That's the preferred one. You can also use KMnO4. I mean, if it were up to you, use K2Cr2O7 always. Okay.
Like if I use KMnO4 is wrong then, like because in
No,
MS
it's not.
is
I mean, it's इसकी MS में है? क्या इसमें?
like just generally, I think they use K2Cr2O7.
That's what I'm saying. KMnO4,
Yeah.
the problem with KMnO4 is that it's a slightly stronger oxidizing agent, so it's not preferred. Even यहाँ पे नहीं लिखा हुआ. In some market schemes it would be written, in some it won't be written. So KMnO4, if they tell you to use KMnO, I mean, if they're asking you to use KMnO4, that's fine. But if they ask you to write the reagent, then go for K2Cr2O7.
All right.
ठीक है, इसलिए I've put it in brackets as well. Like even in the lab, it's not preferred because it's too strong an oxidizing agent. But it does the same thing. ठीक है, and in some market schemes it's written, in some of them it's not written. So better to go with K2Cr2O7. इसके अंदर it's not written. KMnO4 is not written. As a reaction number 2, what's reaction number 2? What is happening in reaction number 2?
Free radical substitution.
Okay, that's free radical substitution because you have a carbon with 3 H's and all of a sudden you have a carbon where one of the H has been substituted. So that's free radical substitution. What conditions are required for that?
UV light.
Okay, bromine and UV light. Or the next part is it's ester formation. Like you've got a carboxylic acid and the ethanol, which is 1 carbon atom, 2 carbon atom, and it's got an OH. So the OH and H would be lost and they would end up forming an ester at this point. So construct an equation to represent reaction number 1 with O. So I'm gonna write the reaction number 1 over here first. So I've got C2H5OH, and they're saying the oxidizing agent should be used as O, and my products are CH3COOH and 4 H's. So the H's being lost, so those H's are combining with oxygen to form water. So that kind of, you've got 3 oxygens, there should be 2 oxygens over here. So that is my oxidation equation, the first one. And suggest the type of reaction with free radical substitution, that's also done. Explain why H2SO4 is described as a homogeneous catalyst. What's a homogeneous catalyst?
In the same phase as the rest of the reaction.
In the
As
same
this-
state.
same state or same phase as the rest of the reactants. Now, this is about infrared. You probably lost here. There's another question after that. So this one is about infrared. He's saying that reaction 2 needs to take place in the absence of water to prevent the formation of compound C. C is this thing. If C is present in the reaction mixture of reaction 3, a different compound D will also form. Compound D has 2 identical functional groups. So that's so he's talking about reaction number 3. And what is he saying about reaction number 3? Okay. So what he's saying is that if water is present, so if this thing is present, what he's stating is that the Br will get substituted by OH. There's going to be hydrolysis. So the product will have, instead of Br, it's going to have OH. That is what the question means. I mean, they drew the molecule. Instead of the Br, you have an OH. That's it. So if C is present in the reaction mixture of reaction 3, a different compound D will also form. And compound D has 2 identical functional groups. So let's focus on D over here that I've drawn. He says compound D has 2 identical functional groups. That also makes sense. D would not actually be this one. It's what will happen is, so I'll just rephrase the question first. So what he stated was, if water is present, this thing, instead of the Br, you'll have an OH. And then you're adding ethanol, you're trying to make an ester. So let's go over here. If I try to make an ester out of it using ethanol, Use D, identify the functional group, and D, explain your answer as fully as you can. And he's saying D has two identical.
So wouldn't it hold over itself, like the it become a, what's it called, like a cyclo ester?
I mean, that's a possibility. So, but they're adding ethanol as well, right? So he's saying if C is present in the reaction mixture in reaction 3, and it says two identical functional groups. As the first thing, he's added ethanol as well, right? So let's add in ethanol. So what will happen? The OH would be lost and the H will be lost, and they would end up forming an ester. So that's one compound. You'll have acetyl bond O, and you'll have CH2 and OH on this side, and over here on this side you'll have an O and CH2 and CH3. But the problem is that that's not an identical functional group. You got this group and you got this group, so it's definitely not identical. Can it form two esters? Because remember, it has to be identical. So let's start again. I got acetyl bond O, and I got OH on one side, and the other side is what? It's got an OH as well. So it can fold on itself as well. So let's focus on D first. So you're getting two strong absorptions at 1720 and 1100. So at 1100, if you look at the data booklet, that's C single O. Where's the infrared spectroscopy? So 1100 is C single O, and you're getting an absorption at 1700 as well. That's acetyl double bond O. So you're getting these two absorptions. So based on this, you got a C single O, and you got a C double bond O, and there is no OH group, right? So when you have C single O and C double bond O, you're going to have both of them when there is an ester. So both groups are an ester. So he didn't ask you to draw D. I was trying to draw D, but I couldn't really figure out what D was. But the only group that's possible based on the infrared spectroscopy is an ester. So both the identical functional groups are esters, and that's what we've figured out. Is that clear?
Yes.
So sir, what it's 3 marks, so what would you write?
I mean, that's it. You 1 mark for this one. That's C single O, 1720, that's C double bond O. And based on that, the conclusion is they've already told you that it doesn't have any OH bonds. So based on that, the conclusion is that it's an ester.
Yeah, okay.
Okay. They didn't really ask you to draw D. I was trying to draw D, but I wasn't able to get rid of this other OH. So maybe it's some other reaction. But they didn't even want you to draw D. They just wanted to figure out. कहाँ गया हमारा? इसके बाद भी एक है. So this one 1100 1720, that's 1 mark is for the ester, and there's another mark that was given for, since there is no OH. This was pretty obvious, but they said that since there is no OH, so it's not a carboxylic acid and it's not an alcohol. So you had to write this one. So we lost 1 mark for this. So you had to write this as well. As anyways, a few steps left after this as well. Draw the structure of E. What is E? Na2CO3. What happens? The carboxylic acid would react and it will form a salt. Is that clear?
Yes.
So what is F over here? F is a diol. CH2OH. So it's got CH, 2 H's. And over here you got 2 H's as well. And you got an OH, right? So
So
you got
structure
CH.
वैसे क्या होगा E का?
E ka? It's the same
Yes.
structure. Just that this part is carboxylic acid, so it will become COO -1 and Na+1.
So just substitute Na instead of OH.
But it's just that you got a carboxylic acid. So when you react it with the metal or a base or an acid, it will just form a salt. The OH at the end will be replaced by Na, the H in the end.
Do you need to show the minus?
You can write O -1 Na+1. Usually you do need to show that.
All right.
It's all those except here where it's ONA or O -1 Na+1. Okay. I just suggest why NaBH4 is not a suitable reagent to make F from C. Why is it not suitable to? I mean, this is reduction. You got CH2OH alcohol, you got a carboxylic acid. How do you reduce a carboxylic acid to an alcohol? What reagent is used?
NaBH4.
No, that's not NaBH4. To reduce a carboxylic acid, you use an LiLH4.
Oh, okay.
And the reason is that that's a stronger reducing agent. Carboxylic acids are not easily reduced. You need a more powerful reducing agent for that, and that's LiLH4. उसके लिए एक वो जो दूसरा है ना, for that you use NaBH4.
Yeah, aldehyde to alcohol.
For ketones to alcohol as well. You can use NaBH4 or LiLH4, both of them. But not for carboxylic acid. Carboxylic acid, you need a. So the explanation that you're going to write for this is that it's not a powerful reducing agent. Construct an equation for the reaction of CH2OH with SOCl2 to form G. So what is the equation? It's CH2 and OH, and that's twice. With SOCl2, the product is given above. That's CH2 and Cl2, right? So what do you think is the other product that is formed? You got two Cls substituting the two OH. So what am I left with? I'm left with the two OH. That's one of them. That's another one. What else am I left with? I'm left with one sulfur and one oxygen as well, right?
Yeah.
So what do you think all of these combined would form?
Sulfur dioxide and water.
Water and sulfur dioxide.
SO2 and H2O.
Water and sulfur dioxide is a possibility. H2SO3 is also a possibility. Because sulfur dioxide and water, they actually combine to form H2SO3. I'm not sure which one is it, but both of them, they look fine. So they went for SO2 and H2O. Why didn't? But I guess that would be acceptable as well, H2SO3, because SO2 and water, they actually combine to form H2SO3. So no idea why not the other one, but I'm guessing that one would also make sense. Because again, this question is not in your course. So, and they haven't told you whether it's what type of conditions are being used for this reaction. No conditions were given or assigned for this reaction. So I guess that would also be a possibility. Explain why C is very soluble in water. What is C? I said, why is C? I mean, that's a simple question. Why is it soluble in water?
Hydrogen bonding.
So it can form hydrogen bonds, and water can form hydrogen bonds, strong hydrogen bonds with each other. How many marks is this? This is just 1 mark. So that would be it. I mean, hydrogen bonds with water, that's it. No further explanation for 1 mark. Okay. So we're done with this question. We'll try and do more papers. Okay. Next class, maybe.
So is it possible for you to save and send this paper?
Yes.
So is it possible for you to save and send this paper?
ये वाला मैं कर देता हूँ सेव। हाँ ठीक है, मैं कर देता हूँ। ठीक है
सर वो कोई आप डेफिनेशन भी भेजने वाले थे?
हाँ, वो भी
डेफिनेशन लिस्ट।
मैं भेज देता हूँ, भेज दो। ठीक है,
ओके सर।
ओके।
Alright, so sound.
Yes.
Love to see.